right. Welcome, stream team, to the data findings meeting. We are so excited to have you here tonight. We want to get started with your name, what county you are from, and what site you monitor. You can go ahead and put that in the chat. I know Caitlin got us started representing the Yellow Breeches. And as always, you know the housekeeping at this point. Please put your questions and comments in the chat. Please react to things. And please remain muted to reduce any feedback. And so tonight, we are going to spend the next 2 hours. We did extend our time to allow for more time for folks to be able to share. So we originally did advertise ending at 7:30, but we are going to be around till 8. So we're starting out with our goals, and then Phoebe is going to review the data interpretation materials that we've given you and what we've walked you through thus far. And then we're going to open the floor to some volunteers that have curated some slides and curated their findings about their own sites. And then we're going to take a 5-minute human needs break. And then when we come back, we're going to do a data deep dive with our very own Candy Wilderman. And then we'll have some time for some questions and conversation. And I'm going to look at the chat really quick to see who is here. Oh my goodness. I love seeing the diversity. Even got Clinton County. Whoop, whoop. All right, Phoebe, take it away.
Alrighty, so hello everyone. Again, thank you so much for being here. It's great to see your faces, and we are so very excited to hear the stories that you're pulling out of your data later on. But before we dive into that, however, I wanted to just look back at the entire process that we've gone through from December of last year to today. So before y'all were even given your data packets, we had spent December 2021 to March of this year downloading the data from the Data Explorer. We went through it, we cleaned it, we wanted to see if there were any quick errors in it, which we reached back out to y'all about. And once that was done, we created some maps to give some extra context to your data. And then once all that was collected, we were able to then put them in the data packets that were sent to y'all in early April. Around a week later, we had our huge data exploration meeting, which was that 2-hour meeting that kind of gave you the primer of what influencers would be affecting your stream and what that would look like in your data, like land use, geology. We gave a brief primer on policies and other statewide things that would affect your stream. And then we gave you a little bit of a preview on what interpreting your data would look like. From there, after that meeting, which was a lot of information at once, we gave y'all your homework to see what you can figure out in your own data. And with that, we offered our office hours for a few times. So thank y'all for everyone who came to those. It was great seeing you. And after that, after you gave your homework a good go, you were able to then put all of that information together into slides with the summary of your findings, which we'll be seeing really soon. And all of that brings us to where we are today at the open meeting, where we can now discuss your findings and see how sites compare to each other and see what it looks like from county to county, because you all are from different locations. So that is a very brief overview on the entire process. And even after this meeting, for anyone who is interested and wants to go back and review, even the data exploration meeting was recorded and can be looked at later on if you needed a refresher. So let's look at the process. So we can go to the next slide. Fantastic. So thank you again for everyone who attended our office hours. As the outreach manager, it would have been remiss of me if I didn't snap a couple photos here and there. So thank you for all who did attend. It was great seeing you both in person and over Zoom. And we really appreciated getting to hear your questions and how you were working through the entire process in real time. So that was wonderful. So bringing us to where we are now, the way that we got to the templates that you're going to see in just a minute was this lovely homework that you're seeing on the left side of the screen here. So by answering some questions about the maximum values in your data, the minimum values, bringing in some of your local knowledge that only you would know best, and answering questions about your site. You were able to fill it out in the worksheet. And then I know the hardest part was probably figuring out the most important things or the most interesting things to put in your reporting template, because I know you can pull out so many stories in your data. But where we are today are the reporting templates that y'all provided, and you will be seeing real soon. So that's a brief primer on the entire steps from December and today. It's been quite a robust start of the year and a good 6 months. So 6 months have brought us to where we are exactly now.
Thank you, Phoebe. Yeah, so to get started with the next portion is going to be the sharing of your findings. And so we're going to structure this like a lightning talk. So this is, you know, a little bit longer than what you would consider an elevator speech. If you had like 30 seconds with someone in an elevator, we're going to give you 4 minutes to be able to share the most important things you found and aspects about your sites. We do have an order here that all of the slides are in. We did include some folks at the end who did participate in data office hours. Even if we weren't able to get slides from you, you did participate in office hours. So we wanted to hear about your findings. So we included some slides for you. Real quick about the lightning talks. We have a special guest on our Zoom. And I am trying to find our special guest. Phoebe, do you know where? There it is. I'm gonna pin it. Our special guest is this blue sky timer. Everyone should now be seeing it in front of all of the faces on their taskbar of, you know, video faces. And so this timer, we're going to start it for 4 minutes, and it'll be on the screen available for you to see how much time you have left. And then at 1 minute, Phoebe, did you make it have a time for 1 minute or 10 seconds? 1 minute?
At the 1 minute mark.
So there's gonna be like a little bell at 1 minute. So you know that you have 1 minute left and the color will change. This is something new that we're trying, but we wanna do it so that we can make sure that everyone has plenty of time to share about their slides.
Can we get a thumbs up to see if you could see the timer right now? Good. Seeing some thumbs, some nods. Any head shakes, or are we good to go?
I see some thumbs up. Everyone can see our special guest. How fabulous.
Fantastic.
All right, well, so Greg John, you are first. Are you ready?
What?
You're first. You're the first one up.
All right.
Are you ready?
I am ready. I've got notes in front of me. I'm ready to rock and roll.
Awesome. All right, well, take it away and let me know when you want me to advance your slide.
All right. Well, let's just stick with the first one for a minute because I want to talk to some things there. I'm Greg John, and my site is on the Conde de Gwinnett 6.09, which puts me about 6 miles just west of the way the crow flies, because we know what the Conde de Gwinnett does. The way the crow flies, 6 miles west of the mouth into the Susquehanna. So I'm a victim from everything else that you all passed down to me. I've got all kinds of chemicals in the stream probably, and at the same time, with the volume of water that's at my site, we've got a lot of dilution. So what you might see in higher concentrations near polluting sources or upstream when the creek is much narrower and much the volume isn't as great, you don't get that downstream because of all the dilution. It is a designated impaired area from the standpoint of being a warm water fishery. We're pretty much smack in the middle of those two major rock bodies, the shale being predominantly to the north and the limestone being predominantly to the south of the creek. So you get the effects of both. You get the runoff from the shale, and you get the breakdown and the percolation through the limestone. Favorite features of my site, if you ever get a chance to get to Acre Meadow Park. It's a cute little park at the western edge of East Pennsboro Township. There's a neat little island out in the middle, and now we've got a new, I think, an inhabitant, probably seasonal, but inhabitant island. The last 2 times I was down there, and they were 2 weeks apart, there's been a mute swan swimming around. They do pass through here, but given that I've seen it at the same spot twice over 2 weeks, I'm guessing there might be a nest nearby, most probably on the island, because the island's high enough, but it's far enough away from predators. There is a park there. There is some wetlands area. The park's going to be redone soon, or at least part of the park is. But as far as I know, they're preserving all the wetlands area. We can go to the next slide, Steph. Okay. There's not a lot of ahas in this data. Again, I'm going to credit it to the fact that I'm so far downstream that there's a lot of dilution. Boy, I'm out that already. Conductivity stays in a very, very tight range if you get rid of the outliers. The same way with pH. In fact, if you look at pH and you look at running averages, it stays between 8.25 and 8.5. It is a tight distribution with 12-month running averages. Something I want to do in the future is start looking at quarterly running averages in the data and see if there's any aha moments in that. The nitrogen nitrates does require a lot more study because as I've only been on the site for 2 years and there's a lot of variability. I was expecting to see those higher in the summer because of farming. But Stephanie reminded me when we talked, yeah, but the fertilizer's put on in the wintertime, and there's not a lot of ground covering in the wintertime, and there is a lot of ice, a lot of hard ground, which means we get more runoff. So the nitrates, by and large, maybe even higher in the winter than they are in the summer. Temperature, very consistent over time, given its seasonality. If you look at my other site, which is the spring on Orr's Bridge, you get a much tighter temperature band because it's water pouring right out of the mountainside. But the Conde de Gwinnett being a warm water stream, it gets warm in the summertime, and I haven't seen it freeze over for many years. Once upon a time, you could walk across this creek in the wintertime. I don't know that I would have tried that in probably the last 8 or 10 years.
I'm sorry to cut you off, but we have reached our 4-minute mark.
That's fine. I was done anyway.
Thank you so much for sharing.
Yeah, thank you so much. And I just want to point out that Greg has, put together his graphs. Brava, Greg. That's great. All right. So next up is we have Joe and Christine Boyle. Are you ready?
We're all ready.
Perfect. All right. And let me know when you're ready to advance.
Okay, so our site is Abrahams Creek here in Luzerne County. It's actually contained where we test is within the Francis Slocum State Park. It's a small, obviously it's a small area where we drain approximately 3 miles, and it is an unimpaired cold water fishery. The reason we selected the site and we sort of connected with the conservation district here. But we selected the site because this stream feeds into a lake that has some significant issues. It has harmful algae blooms, lake coloring changes significantly over the course of the summer as the temperatures get warmer. And so we were sort of interested to see what impact stream, the water coming into the creek may or may not be having. It's being a state park, it primarily consists of natural areas. There is agricultural area here, and historically the lake was used, the site where the lake is now did have agricultural usage. There's a footbridge right where we test, so people can access it from several different locations, from different places in the park. It's really pretty pristine. We don't typically see litter there. We typically see the same woman there every time walking her dog when we're testing for whatever reason, so it's great. And there have really been no changes in the use of the land certainly since we've been monitoring. So we can go to the next slide. We have, from the perspective of conductivity, pH, nitrates, there really is very limited change. All three are stable and are consistent with what we would see with given the natural area being the dominant use of the land. The water temperatures generally do stay within the cold water fishery range, but we did see several exceptions, both in wintertime, where we had at least 3 instances where the temperature fell below the bottom end of the range, and then we've had at least 4 temperatures where it actually was in excess of what we would expect to see as the range. And so that's obviously something that's concerning. Presumably it's climate change impact, but maybe over the course of the next year, we can do some more comparisons. And so our major takeaway that we've discussed with the team is maybe reconnecting with the conservation district to see if there's another area they'd like us, to test, maybe from the exit where the creeks exit from the lake, or someplace else where they might want to see the data that we're collecting.
Yeah, it's a really nice site, but our findings are, kind of boring.
Which is good for the creek.
Yeah.
But
it doesn't solve any of our questions about why the lake itself looks like it does. So, and it is probably the main source coming in there, but we got to do some more investigation.
And we will yield our remaining time unless Joe's prepared for a recitation. So,
That's awesome. Thank you so much, Christine and Joe. All right, next is Jamie. Jamie, are you with us tonight? I think I saw.
Yeah, can you hear me?
Yes, I can.
Okay, so I've got east branch of the Codorus Creek. So it's where it enters into Lake Redmond, and I sample at Log Road. So it's a little bit difficult to sample there sometimes in the winter. It's deep and there's rocks on the side, and I've slipped a little bit once in a while. So my temperature readings that I get, I would really kind of like to get a more, standard way to measure the temperature, but I haven't figured out how to do that yet because I can't stand on the bridge because there's a surprising amount of traffic on that 1-lane bridge. So it drains 11 miles squared. It's impaired for aquatic life. It is a cold water fishery kind of before it gets there. It's a non-carbonate 100%, 35% ag, 45% natural, 20% developed. My favorite feature, so I talked about Log Road and the depth right there. When it's clear, I can see a surprising amount of fish. At least it's surprising to me in the size. So no wonder why I do see a lot of fisher people around in that area. And there's a lot of fisher people in Lake Redmond. Anybody who fishes there crosses a bridge. So it's that area right where I'm at. As I mentioned, it's proximal to fishing. A lot of hiking, a lot of biking goes on. The back before it, where it drains, there's no known recent land use changes. So I looked at a couple of different maps, including USGS, and it was kind of based on my findings. And it looks like that the stream is really well buffered all the way where it drains. It doesn't really go up into Shrewsbury, or Dallastown, where there's some significant development. So it's kind of interesting because even though it is ag, it appears to me like the forest buffer, and it does appear to be. Oh, can you next slide, please?
Yes.
So let's see. So I did see a slight seasonal pattern, but getting back to what I was saying before, the conductivity is really a pretty narrow range. And so is the nitrite, which seems to be responsive to the water temperature in the summer. What I did is I looked at it Next slide. Let me see if I put the,
Don't think there was another
oh, just two?
slide.
Oh, well, oh dear. Okay. So I compared it because it's really, there's not a lot of variability here, which I found really interesting when I looked at several different sites. So I looked at the Muddy Creek, I looked at South Codorus. I actually looked up north to kind of match a little bit the land use, and mine still was like really buffered, not a lot of change in it except with the temperature. So I found that very interesting, and I kind of just to a theory that I think that might be that this could be a demonstration of an effective forest buffer.
Mm.
That's it.
That's awesome. Thank you so much, Jamie. And I'm sorry if I dropped your third slide.
No, I must have didn't send it or something. Oh, well.
Oh my goodness. Well, that's very awesome. Okay, we are doing great. Next up, we have Jane and Randy. Were you all able to get the connection?
Yes,
Okay, we're
it
here.
was in our spam folder,
Oh
I think. Yeah,
Yeah.
so we weren't sure we were gonna be able to get on today, but we found it in the spam.
no. Oh my gosh.
Well,
Well, let me know when you need me to move your slides.
Okay,
okay, thanks. Okay, our site is on the Conocoquina Creek at the Scott Farm, right where the AT hits the creek. We have an emotional attachment to this site. We've had it for quite a while, and having hiked the trail, we're very comfortable being on the AT. So our site is a calcareous, the limestone type, shale and limestone type of area where it's a warm water fishery. The area is 49% agriculture, 38% natural area, and 13% developed. We do our sampling right under the bridge, directly on the AT, and the area half-mile upstream and downstream is in the AT buffer zone, so we have quite a bit of natural area. The background of the slide, as you can see, is through all the printing, is the bluebells in April, which are pretty magnificent on this stretch of the Appalachian Trail. Next slide. Okay, so this is like I said, is a warm water fishery area, and typically that ranges from 4 to 30.5 degrees Celsius, and it's seasonally variable, as you could understand that. And 92% of our water temperature readings are in that general area. We have a couple exceptions which correlate well with the air temperatures on those days. And there's seasonal variability, of course, for the same reason. We did notice a general trend of higher than usual nitrate readings from August of 2020 through February of 2021, and some higher than usual conductivity readings also. And our conclusions, at least, were that there was a increase in the amount of nitrates, which is probably agricultural runoff. Could also be if there were sewage leaks or leaks from other type of agricultural processes. So that would increase the ions in the water and would give us higher conductivity also. Next slide. Okay, so also we noticed a slight correlation between lower nitrate readings and rain events, which would when they were closer to sampling. And that also makes sense from a dilution point of view. So we had a few nitrate readings were below our median reading of 4, and 8 rain events, which were closely associated with the sampling date. 4 of the lowest nitrate readings were taken on sampling days associated with rain events. And an online research of local rain events history did not, however, support this correlation. So we would expect the nitrates to be higher due to runoff rain events. So again, we have either dilution effect or it's just, of course, there's always coincidence. On a future plan, we'd like to quantify creek depth by using a gauge stick and make more detailed notes about rain events on or prior to sampling. Right? What are we doing? Oh, 39 seconds.
Hey, perfect.
Perfect.
Any last thoughts you want to add?
We made it, we made it.
Well, bluebells in April, but Dame's rockets in May. And
Yeah,
they- And they're equally as beautiful.
Yeah, the Dames Rockets this year were quite spectacular also, so. Yeah, it's a nice place to walk.
Awesome.
We usually get in a hike before we take the sample, so.
I will have to share with everyone your rockets picture. They're beautiful. All right, next up, we have Sean and Cindy. I know I saw Cindy in here. Are you ready, Cindy?
I think so. You ready? Can you hear me?
Yeah, we're ready to
Terrific.
hear you. Let me know when you want me to advance your slides.
All right. My name's Cindy Fizzichetti. I get to monitor the beautiful Kreitz Creek here in the mid-eastern part of York County. 8.67 miles from the mighty Susquehanna River. That's where we monitor. I'm right there at the park. It's a really beautiful site. It's easy to get into. I love it. I got into this because I wanted to know more about my water and the water quality around me. I live in the Kreitz Creek region, and so there's tributaries and water all over the place, it feels like, from this creek. You can advance it. So my watershed isn't really large, but it's really pretty from my perspective. And it's like almost a 30-30 mix of, there's some developed areas, there's some ag areas, and there's some natural areas. So it's quite a mix. And as a master watershed steward, I wanted to know what's happening in the creek, what's happening to the water qualities. Are the best management practices that we're espousing, that we're trying to get farmers and everyone to do, are they impacting the creek? Has there been changes and stuff? And this is what I found. So next slide. So I just focused on 2 of my data findings instead of going through everything. The first thing I saw when I got my data findings back was that minimum conductivity of 274. And that blew me out of the water, because 274 is way out of the range that we normally get at my creek. My creek runs between 400 and 600 pretty consistently. But if you get a rain event, which we know we're getting much more of that, of over 150 millimeters in the week, with 50 millimeters coming within the 24 hours prior to this monitoring, the minimum conductivity makes perfect sense, because there was a lot of dilution that day. Minimum nitrates is 0.5, and 0.5, believe it or not, I aspire to that goal. I want 0.5 to be my goal all the time, but that's not how my creek is. It runs high. Maximum conductivity goes along with that maximum nitrates. Next slide. The reason for that is the point source pollution. My creek, 3 miles from where I check it, is being polluted by the landfill. Next slide. So the water looks like this when it comes out of the pipe. It was a landfill. They put a water treatment plant in to treat the water, the leachate that forms in the bottom of the big landfill things. And for a while, it was working well. It was a Superfund site that now was being effectively managed with this wastewater treatment plant. In 2018, the landfill started having problems with the wastewater treatment plant, and there were violations to their pollution permit. It took the Environmental Protection Agency until 2020 to file an order of consent, where they reached an agreement through a judge to say, we're going to make these changes and improve the wastewater treatment plant. None of those changes have happened to the wastewater treatment plant. My creek continues to be polluted. The only difference I can tell in my water quality comes with whether or not the landfill is actively polluting and how much they're putting into the creek. My source, I never imagined that my story would be one of, if you see something, say something, that my monitoring would point out to me how badly the pollution's happening. I go out and tell kids that Clean Water Act has changed things. Apparently it hasn't changed things in my neighborhood, because apparently polluting is just the cost of doing business for these people, because they're being fined continuously because they're outside of their parameters for pollution discharge permit. And that's my sad story.
Ah, Cindy, thank you so much for sharing. Your site has definitely seen a lot through Stream Team, and we're very grateful that you are spending your time monitoring there. So thank you, and thank you for sharing the history with us. Ah, gets me emotional thinking about that. All right. Next up, we have Gary and Judy. I know I saw Gary online.
Yeah, I'm on. Judy and I monitor the big Wapwallopin Creek. We're in southern Luzerne County, and our site is pretty far down in the watershed. So there's 2 farms below us and then a little gorge, and then we dump straight into the Susquehanna River. So Stephanie, I selected 3 slides. Could you show my first one?
I don't remember which ones I included, so you tell me when to stop.
Well, keep going. How about this one?
Yeah.
Okay, so I'm going to jump right to the data. What's unique about our site is there's a USGS gauging station directly next to where we sample the water. So what we did is superimpose the stream flow over our graphs here to see if the data varied by flow. And unfortunately, our thinking is we really don't show anything unique or anything unexpected. Maybe if we did this over a 2-year period, we'd see some type of hiccup. But right now, our data is pretty much what we expected. So I'm glad we plotted it against flow, but I'm not sure it really taught us anything. Let's go to the next slide. So thinking about climate change, we decided to take advantage of that gauging station. And on the right side, I've plotted the last 10 years. And if you look at that, it looks as though the last 3 years, we've had more high water events. So, I mean, when I think of climate change, I think of warmer temperatures, and I think of more thunderstorms, more weather events, more severe weather events. So just looking at this, if you look over towards the right, the last 3.5, 4 years, we are having obviously more thunderstorms and more high water events. So let's go to the next slide. Okay. First item there is we wanted to select a site that was fairly low in our watershed so that we knew exactly what our contribution was to the Susquehanna River. And I think by taking advantage of the site and the landowner permission we got to sample here, whatever we're measuring, that's pretty much what we're delivering to the Susquehanna River. And fortunately, it's pretty good. There is one impaired section of the creek, though, upstream from us, and it seems that the Mountaintop Sewer Authority is our contributor. And so there's a tributary that comes in just upstream from us. They say the solution to pollution is dilution. So the I feel that our readings that we've been getting have been diluted enough so that the rest of our creek from where we're testing down is attained. But I think we need to keep a close watch on it. So I'm just wondering if in the future, if we shouldn't really be testing for something else. So anyway, it's something to consider for the future. And then lastly, because of what we saw on our gauging station results, it looks like with more high water events, we need to keep a closer watch on stream erosion, make sure we have suitable riparian buffers, because we've got more acres, I guess, of soil that's just not holding the water. I mean, it's just running off And so we just need to keep an eye on that. And that's it.
Awesome. Thank you, Gary. And thank you for naming climate change. Oh my goodness. All righty. Letice and Mark. I know Mark is here. Are you ready, Mark?
Oh no, did we lose?
Okay. Our creek is Mill Creek. It's a tributary to the Codorus Creek. It starts almost in Redline, goes through the town of Yo, and then runs along Route 83 and meets the Codorus Creek near Harley-Davidson in York County. It drains 18 square miles. It is impaired, but it's really a tale of two different creeks, which I'll talk about later. It suffers from urban runoff. It's a warm water fishery, but again, a tale of two different creeks, and I'll discuss more later. Most of it is non-carbonate. The very end of it is carbonate, which I think affects our pH. It is a birder's paradise. You can often see ospreys, hawks, and there's an active bald eagle nest 100 yards from our test site. So it's not uncommon to see those birds of prey there. Mill Creek, as mentioned, parallels Route 83. It has no tree cover at all for several miles, which is going to affect it. Okay, I'm ready for the next slide. This is land use, which I'll talk about land use later, but a very small part of it is what I would consider natural, forested. The rest is all affected by human activity, which I consider agriculture, human activity. It produces pollution just like a factory does, or an urban area. So small percentage, about 13% is natural. Okay, next slide, please. Conductivity, pretty steady. There were a couple outliers, but pretty steady. Okay, next slide, please. pH, I think this is the effect of the carbonate rock at the end. Our pH is as steady as it gets. Very little fluctuation. Okay, next slide, please. And boring is good. Nitrate and nitrogen. If you look, there's been a marked decrease in nitrogen recently, which I'll talk about my thoughts on that and why it may have gone down. But there are some spikes in there where it's pretty high, but it's been consistently low recently. Okay, next slide, please. Water temperature has your typical seasonal cycles for a freestone or non-carbonate stream. It gets warm in the summer and cold in the winter. Next slide, please. All right, here's one of the factors that I think affected our creek. There was a construction project on Route 83 and Mount Rose Avenue. If you're from York County, you're well aware of this. It took forever. I have a feeling that some of those spikes in nitrogen may have been a result of this, because riparian buffer was not grown in. It was an active construction site for many years. It took a while for things to come in. The decrease, the riparian buffers are starting to grow in now. Next slide, please. This is a retention pond that's right beside the creek along Route 83. Next slide, please. This is hard to see, but these stones down here, that's Mill Creek, and riparian buffer back here. You can see little wetland back there. So it's all grown in. I think it's doing its job in catching sediments and nutrients. So therefore, our nitrogen levels have gone down. Next slide, please. The temperature, seasonal patterns I discussed. I suspect the riparian vegetation is keeping nitrogen down. I would consider land use to be the #1 factor here. The upper parts of this creek are listed by Pennsylvania Fish and Boat as having natural trout reproduction. And I can verify that. One of the reasons I monitor this creek is because I do trout fish in it. And I have tried trout fishing in the whole length of it. And where they say trout reproduction does not occur, I've never caught a trout there. Doesn't mean they're not there, because I don't catch every fish in the creek. But I've never caught one there. Even through the construction zone, when they had the creek lined by cattle ramps or cattle chutes and covered with plastic, I caught trout in between the cattle chutes, which is crazy. So it's two different creeks. And I figure land use is what causes it to change so dramatically. That's it.
Awesome. Thank you so much. And thanks for bringing in that local knowledge with the construction going by your site. That's really interesting and exciting.
I'm sorry, I can ramble on forever, you know that. They're gonna continue construction, and they're gonna relocate some of the creek, move it as they widen Route 83 in that area. So it'll be interesting to see what happens.
Oh, fascinating. Well, we will definitely love to see some pictures from you, Mark.
Yeah. All right,
Oh,
I'm done.
thank you. All right. So Gil does not look like he is here, but Gil did attend. I'm looking through to make sure. Gil did attend our office hours, so we want to give a nod to Hoagstown Run, which is a tributary to Coneduguanet Creek. I don't remember what we decided with Gil, Phoebe, but we do want to give Gil hats off for spending the time and looking at his data with us. But I know we have Caitlin in the room. Or at least we did. There we go.
Yeah, just had to turn my camera on.
Perfect.
Hi. So luckily our site, as I said during our during the office hours, is boring, but in a good way. But it's great to see that we're 62% natural areas, and I think that's why we're like boring and steady. But I mean, that's a really good thing. One thing that we did notice about the data is that it is a cold water fishery, but the temperatures have been higher than what a cold water fishery is defined as. And I'm concerned that that trend will continue because, yeah, we've got some quite warm spikes there. We have some pretty good tree cover at our spot too, which is also why it's kind of concerning. But I think we're going to see that trend of global warming really be highlighted this year. And I'm kind of curious how summer 22 is going to go, because they have been doing some park restoration, and I don't really agree with what they've been doing. They really thinned out the woods there. So I'm really concerned about some of the flooding that we've had and runoff, and also just that there isn't as much tree protection and things like that. We've only seen it really high once, and that was when we had some flood alerts and stuff, and water almost made it to the parking lot. But I'm always seeing people trout fishing there. It was pretty funny because when it was closed for logging, I was sneaking down maybe 20 feet away from where we normally do. And I just kept waving at the property owner, and they never said anything. So I think when they saw the scientific equipment, they were happy to see me there. And so barn smells really pretty. We have a bunch of barn cats that live in the mill, see lots of birds going around. It can be a pretty mucky, muddy way to get in. And 2 months ago, I actually fell off the log that I used to sample water and ended up falling backwards and ruining a pair of shoes. I was fine. It was just really funny because I was there by myself and I was soaked, and a fisherman watched me do it. So it was embarrassing that someone noticed my shame. But yeah, it's been a great site. We have an actual bathroom there now instead of porta potty. That was part of the park improvements. So it's a really nice site, but I'm curious how their logging is going to change the data this summer.
That's awesome. Yeah, thank you so much for sharing, Caitlin. And please always be safe when you're monitoring everyone.
Yeah, it was, again, I was fine. It was just a very mucky, muddy, wet spot. And down, I laughed the entire way down. So that's what's important. So not injured, but and I've posted a couple pictures of barn cats on the Facebook page. So we have some cute monitoring buddies, and they like to sit there and tilt their heads and stare at me like, what are you doing? So they're fun.
Aw, that's awesome. Every site should have cats, honestly. All right. Next, we have Dave Moyer. I believe I saw you, Dave. There you are.
Okay, hello. I'd like to first apologize. I did have some nice, pretty pictures and things, but I've been away for over a week in an area that has absolutely no internet access, and which was very pleasant, but I could not get stuff to you. So anyway, yeah, Muddy Creek is a beautiful little stretch of water where I monitor is actually at the town, if you call it a town, of Muddy Creek Forks, where there is a museum and a roller mill that is not in operation. The stream has a really nice floodplain, and it is at the bottom of a very deep gorge. There's at least a half-mile of old growth forest on either side of the stream. Any residential places, houses, they're at least a quarter mile away from the stream. It's the kind of place where the houses are on blocks, houses are on wheels, and the cars are on blocks. Lots of wildlife. I love going down there. I've been fishing there since the 80s and fishing downstream from my monitor site. The biggest thing that stands out with my data is nitrate nitrogen. The water temperature is cyclical with temperature. As you can see, conductivity and pH are pretty static. Nitrate and nitrogen, there's a lot of farming off from the buffered area. And it is primarily Amish, which means that they're just spreading pure manure. There's not a lot of cover crop, and they do still old plowing and tilling. They don't do more modern techniques of farming. So there is a lot of runoff of manure, and you can see that with the times of year when there would be that. The one thing I found interesting was the spike in June and July. I did a little research found a website that talked about water temperature, and warmer water will absorb nitrogen faster, and that summer concentrations can exceed winter concentrations sometimes due to photosynthetic activity during the summer months. So that's just something, I don't know, I'll look into maybe a little more. I found it fascinating. One thing I would like to start doing is maybe monitoring Muddy Creek in 2 spots. I'm thinking of continuing to monitor where I am at the Forks and go on down to where I fish, which is considered a Class A trout stream, and there are wild brown trout and native brook trout in that area. So to me, that says that part of the stream is not impaired, and that it is still in a cold water fishery. So, like I said, there's lots of wildlife. Every time I'm down there, I see common mergansers, I see great blue heron, I see bald eagles, osprey, deer, otters, muskrats, frogs, toads, all kinds of stuff. I love it. Any questions?
Do you love your site?
I love my site. It's always nice because I have grandchildren that live down in that area too. So whenever I go to monitor, I always see my grandchildren at least once a month.
That's awesome. Awesome, awesome. All right. So let's see. Don Horn, would you like to share? I did not put your slides in the PowerPoint, but I can open up your slides if you would like to share.
I was going to say, I seen those the other day, but I haven't been able to get them out, and look at or go over them. But we've kind of discussed them before. And
Yeah,
we're
let me.
running pretty much the same stuff Dave was running into with the farmers. And a lot of ours are the Mennonite, the Amish farmers. So we have that issue, and it's kind of neat. He mentioned the sunlight and the change, because that could actually affect some of what we were looking at on our scale as well.
Let me share your packet. I just got it up so that you can. There we go.
Now you can see for a cold water fishery. There's the headwaters where it starts, and forget the first half mile or more is fly fishing only, catch and release. And then it starts where you're allowed to fish with bait and the other fishing utensils and keep fish later or further downstream. There's a lot of runoff in there. I mean, because the creek and the roadway is side by side from the headwaters going down through. So we do get quite a bit of runoff. We did have an area that we think we had a underground movement, so to speak, of water, where it was the creek was maintaining the level where it starts and comes down, but at one point it drops, and then further downstream it comes back up. So we figured some of it got detoured, that's going through an underground stream and coming back out at the other end there. So that's kind of one of the things we've been looking at as far as that goes. I know that they do 2 cleanups there every year. They do one in the spring, one in the fall, and they go along pretty good. That watershed's pretty active. They get some school kids to come out to do some things, and I know a couple other projects that's coming up that we're all working on. I think there's the monofilament line tubes. We're putting 3 of them up on the Big Spring. They're also putting up a kiosk for information about the stream and how it's effective, why we have those areas, why we need to maintain them, and pretty much a good educational board. I think that's 2-sided from what they told me, so it's going to be a pretty good size. So they're through the education and all that. It's going pretty well, and I think we're between the watershed, Penn State Extension, and some others. I think they're going to their Fountain Festival this year, and that's one of the things we're going to go over is, we're going to have this information there to share it with them. Also share about the fishing line collection tubes that's going up, so that they know what they're for and why they're being used, and put it in there. So got a little bit of public education coming up too. Really pretty good.
You have another minute if you'd like to share more.
We're just busy. I got my other 2 signs today. I needed 3 signs, and the other 2 showed up. They just gave them to me today. The only thing is going through Pennsylvania Fish Commission and getting the letters and of agreement all signed and everything, and responsibilities all taken care of. So this project started last year, and we were hoping to put the tubes up before trout season actually started. And we're probably not going to get them up till September or October now. So, but they'll be up there for next season.
Awesome. 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 All right. Well, that concludes the volunteer sharing portion of the evening. I want to give a big round of applause to everyone, whether you attended office hours, whether you presented tonight, or you've taken time to look at your data. That was incredible. And I'm sure we're going to hear more stories in the future.
Wow, it was really interesting to hear all of your analyses on your individual sites. And I'm going to do something that maybe has a little bit of a different perspective. We're calling it a deep dive into the data. I'm going to do a combined site analysis. And I'm going to talk first about what kinds of research questions we have in this analysis, what kind of methods we use, and finally the results and the interpretation. So the strategy, your strategy for finding your stories was an individual site analysis, and the volunteers are finding the stories by exploring questions like what you'd looked and what questions you asked were, how healthy are our sites as indicated by the water quality parameters? Are any water quality criteria violated? Are there any outliers? What seasonal patterns exist? Are there deviations from those patterns? How do the patterns of various parameters compare to one another? And can we identify factors that may have influenced our results? So you all did that tonight. I think most of you hit on every single one of those research questions for your individual site. So these are the sites that are in the data set that we're looking at right now, the Stream Team data set. There's 61 of those sites. And you guys were looking at each of those sites individually. Now, the strategy that I'm taking, which is simply layered on top of your strategy, is exploring relationships between watershed attributes and the stream water quality characteristics by using data from all the sites. And I'm exploring questions such as, does land use and geology in the watersheds impact the water quality in the streams by using all of the sites? And if so, how does it do that? And can we identify causative factors for differences in water quality between groups of sites that have similar attributes? So in a sense, I'm taking more of a bird's eye view. And if these are all the individual sites that you guys are doing the analysis for, I'm trying to look at all of the sites together as a single study. Okay, so those are the research questions. So bear with me while I go through the methodology. And I'll do the best I can to get through it quickly and efficiently, but enough so that you can, I think, appreciate what we're trying to do. And I know for some of you, this is old hat, and for others of you, you probably haven't heard this stuff before. So I'm going to look at three things. First of all, how did we generate hypotheses? What were we thinking about when we generated hypotheses regarding potential relationships that we wanted to test? How did we organize our master data sheet? And then finally, what were the statistical techniques that we used? I'm going to talk about box and whisker plots, which if you've come to former workshops, you've heard about that a bit. And then also regression analysis, which is a very common method that I know a lot of you have experience with. So first of all, generating hypotheses, what are we talking about? What kinds of relationships are we interested in exploring? So we want to generate hypotheses regarding relationships between watershed attributes and stream water quality squares. So if you look at the diagram here, watershed attributes are geology, the carbonate, the non-carbonate, and the land use, the percent developed, ag, and natural. And these are the attributes that were delineated in the GIS that the Alarm folks delineated for each individual site. And we want to take a look and see overall, do these parameters impact these water quality parameters that you guys measured in the field? So here are two examples of hypotheses that we could test. As development increases in our watersheds, the median values of conductivity increase. That's a hypothesis. It makes sense. does it really happen? Can we demonstrate with our data that this is what happens? Another hypothesis could be, as the percent carbonate geology increases in our watershed, do the median pH values increase? And so if we find there's a relationship, then we also want to explore the strength of the relationship. So those are the kinds of hypothesis generations that we've been doing. Now, here's the master data sheet. I think it's just useful to look at this partly so you can appreciate the volume of data that you all are producing, and also so that you can understand how you can step back and rather than looking at individual patterns, you can look at larger patterns and relationships between sites. So we have here the county, and unfortunately on my screen I can't see these headings, but then the site ID, latitude, longitude, and so on. The light green column headings are the watershed attributes, things like the size of the watershed and the land use and the geology. Whereas the blue, the turquoise column headings are the water quality parameters that you guys measured in the stream. And we're looking at things like what is the median conductivity at each site, the median nitrate, the median pH, and it goes on. I'll talk a little bit more about the IQ temp later on. The sites on this sheet, I have sorted them in terms of decreasing carbonate percentage. So if you look at this column where my cursor is, you can see that it goes from 100% carbonate all the way down to 0%. This whole spreadsheet then has been sorted according to carbonate. And then the sites have been color-coded into groups based on how much carbonate is in their stream watershed. So we have the high carbonate groups, we have the medium carbonate groups, and the lower carbonate groups. The next spreadsheet is the same spreadsheet, but what we've done here is we've sorted it in order of development, the percentage development, and we've divided the groups into the sites into 4 groups. These are the high development sites, or the sort of yellow here, the blue are the medium high, the green are the medium, and the peach are the low. So this is the kind of analysis we're doing, looking at sites based on their attributes and then grouping the sites so that we can look at groups and see how one group relates to the other group. So let's talk about box and whisker plots so you understand how to read these. And again, I'm sorry if this is repetition for those of you who've done this before. These plots are really cool. I like box and whisker plots because they show the distribution of all the values of the variable in one little diagram, and it's very visually illustrative. So I really like them. So how do you make box and whisker plots? You take all your data, and your maximum value is up here. That's your top whisker, your maximum whisker, and the bottom is your minimum value. And then your central tendency, your median value or your mean values are somewhere in the middle. The important thing is this box. And this box here, you can think of it as that is the area that contains 50% of the data in your data set. So if you're looking at conductivity, that contains 50% of your conductivity values. And so if you come over here and you look at 2 box and whisker plots, you can see that the blue one has a fatter box or a higher box, a bigger box, as it were, than the orange one. So that means that on the orange site, whatever it is you're measuring, there's not much variability. 50% of your data points fit within a very narrow range. Whereas in the blue, you have quite a bit of variability. Your box is bigger. So box and whisker plots can tell you about variability, and they can also tell you, of course, about the absolute values. For example, the blue box, and just as an example, the maximum, the top whisker, is actually lower than the orange box's minimum. And so the orange has higher overall values, but they don't have much variability, whereas the blue have lower overall values, but they have quite a bit of variability. So these are all things that we're going to look at. Let me show you a real example. This is data that you guys collected from the Cana de Gwinnett. This is water temperature. And these sites here are 6 sites as you go downstream that have quite a bit of variability in water temperature. Look at how long and drawn out those boxes are. But then there's these 3 sites up here that have much less variability. And if you look closely, you'll notice that these 3 sites are actually mostly limestone sites, whereas these sites are mixed geology sites. And these sites have less variability. And you'll also notice that the maximums are lower than these sites and the minimums are higher than these sites. So you have a typical limestone pattern where you have less variability and your winter highs or your winter lows aren't so low and your summer highs aren't so high. And so box and whisker plots show this very, very nicely. Here's another example, and this is actually from the data I'm going to show you today. And this is looking at groups of sites. The orange are sites that are highly developed, and then medium developed, and then medium low, and then finally low developed. And we're looking at conductivity, and you can see very clearly that although the variation is pretty similar, the variability is similar in those 4 groups, that the highly developed sites are showing much higher conductivity. And as you go down, you step down into the less developed sites. More on that later, just trying to illustrate box and whisker plots. Okay, so now we get to regression analysis. So regression analysis is used to examine the relationship between 2 variables. And this analysis determines how the variables are related. Are they inversely related to each other or directly? In other words, as one increases, does the other increase, or as one increases, does the other decrease? And it also looks at the strength of the relationship as well. So to evaluate this relationship, we plot all the points on a bivariate plot, and I'll show you this in a minute. And we draw what's called a best fit line. And then we use a value known as R-squared, or regression coefficient, to evaluate how tightly the points cluster around this line. If you don't understand this right now, if you haven't done regression, it's going to be clear, I promise you, in a minute or 2. The tighter the fit, the stronger the relationship. R-squared goes from 0 to 1. If it's 0, there's no relationship. If it's 1, it's a perfect relationship. Now, in very complex natural systems like streams, the R-squared values between any 2 variables tend to be relatively low because there's so many other factors that may affect any one variable. So what do we mean by all this stuff? Let's get away from streams for a minute and let's talk about something completely different that's easier to imagine, perhaps. We're going to talk about the relationship between age and height in children. So we have here's our data. We have 26 children, and here are their ages from 2 to 12, and here are their heights. We take that data and we plot it, age on this axis, height on this axis, and every one of these points is a child, correct? And that child is defined by its age and its height. So we plot it in age, height, space. Then we draw a line that is the best fit for those points. Okay, and that's the line there. That's called a trend line or best fit line. And then how good is that fit? We calculate an R-squared value. And in this case, it's 0.9016, which shows that there's an extremely strong relationship between age and height. And that age, the variability in the age, can actually explain quite a bit about the variability in the height. Not everything, but quite a bit. And one way to look at an R-squared value is if you change that decimal into a percentage by moving that decimal point over 2, it's 90%. That means that the variability in age can explain 90% of the variability in height. 10% is due to other things. Okay, let's look at some more data on these kids. All right, here's your children. Let's look at this one, the ages, and we're going to look at how many hours they sleep. And there they are there. So we plot this data on age, hour, sleeping space. Each one of these points is a child. And you can see, this is a little bit different. This is going in the other direction. It looks as though the older they are, the less they sleep. Let's see how good a fit that is. There's our best fit line. And here's our R-squared value. Well, R-squared value is only 0.51, which is okay, but what that's saying is that variability in age can only describe 51% of the hours that kids are sleeping, that the other 49% is due to other things. And finally, we're going to look at the same kids and the age and the miles traveled per week. And we can plot them in age, miles traveled per week space. And these are all the kids plotted there based on those characteristics. We put in a trend line. It doesn't really go up or down. It's kind of horizontal. And look at that R-squared value. It's very, very low. Only 0.3% of the variability can be explained by age. It's virtually useless. So we consider that not much of a relationship. Okay, let's apply this to our data. Go back to streams, and here's our data. Here's our site IDs, and what we're gonna take two variables. We're gonna do the percent developed against maximum temperature. And that might be an interesting hypothesis. Is, you know, as development increases, to the maximum temperature that we've been measuring, does that also increase if we look at all the sites? And so all these points, each point, these are 61 points, each point is a site. Percent developed, does it impact maximum temperature? R-squared value, pretty low, probably not. Okay, and what this is basically saying is the variability in the percentage of developed land in the watersheds can only explain about 3.2% of the variability in maximum temperature. So it's not particularly useful. The higher this percentage, the higher the R-squared value, the better predictor one variable is of another. So basically what we're saying here is that percent developed in the watershed is not going to be a very good predictor of maximum temperature. Too complex. All right, I'm done with the methodology. We're going into our results, and I'm very happy to be done with methodology, and I think you're going to like the results because they're really cool. Okay, first thing we looked at, does land use in the watershed significantly impact conductivity concentrations in the streams? All right, so here's our regression curve, percent developed against median conductivity. And you can see that as development increases, median conductivity tends to increase. The R-squared value is 0.4084. So 40%, that it means that variability in the percentage of developed land watersheds can explain 40.8% of the variability of conductivity values. Well, given the complexity of aquatic systems, that would be considered to be a strong R-squared value. I was actually surprised that it was so predictive, in a sense that developed is so influential in terms of determining conductivity. And again, if we look at the different groups, the highly developed to the low developed in box and whisker plots, if you prefer those because they're so much more visually appealing, you can see that you step down as you go into less developed. You do get the distribution of the median conductivity values in those groups is much less than the distribution in these groups. Medians are less and so on. Variability isn't that much different. Okay, so if that's the case, how about ag? Let's look, does the percentage of agriculture in all of our sites, can that predict median conductivity? And in fact, the answer is no. Agriculture doesn't have nearly the close relationship to median conductivity as the developed does. And so that was kind of an interesting conclusion. Now, looking again at our data, does the land use in the watershed significantly affect nitrate concentrations in the stream? Well, let's look at agriculture. Here's the percentage of agriculture. We normally think of agriculture as having an impact on nitrates. But if you look at the data, I mean, I gotta admit, when I looked at the data, just kind of eyeballed the data, I couldn't see anything that looked like a pattern. But if we look at median nitrate and percent agriculture, we do indeed see that there is some predictive value there. There is a relationship there. And here's our box and whisker plots from the highest percent agriculture to the lowest. And nitrate does make a difference. The higher nitrates are definitely in the higher ag sites, and the lower nitrates are in the lower. Now there are some outliers and so on. So does the same thing happen, for example, with percent developed? And in fact, the answer is no. If you look here, percent developed doesn't have nearly the impact on, or the relationship, the tight relationship, the close relationship, the predictive relationship with nitrate as ag does. So that was really interesting. Okay, does geology significantly impact median conductivity? And so we looked at percent carbonate against median conductivity. And as you guys, many of you mentioned this in your talks, indeed, there is a relationship there. And here are the box and whisker plots. The variability of the percentage of limestone in the watershed can explain 37.2, a little more than a third of the variability of the conductivity readings. The other 2/3 are due to other things, but that's still an important influence. Now, does percent carbonate does that have a relationship with nitrate? And the answer is, not really. It's not really high enough to make much fuss about. All right, now does geology or land use significantly impact temperature variability in our streams? Let's look at geology. So what I used for temperature variability was the size of the box. Okay, in the box and whisker plot, it's called the IQ range, the interquartile range. I used the size of the box. So it looks as though as percent carbonate in the watershed increases, the size, the variability of temperature does in fact decrease. It's not terribly strong, but it's getting there. It's about a little more than a quarter responsible for that. Okay, and if you look, what's I think even more interesting, if you look at the groups and you look at those, these are all the sites with greater than 50% carbonate, and these are the sites with less than 50% carbonate. And this is these aren't box and whiskers, these are just bar graphs. This is showing that the mean, this box, the size of the box or the interquartile range is only 6 if there's a lot of carbonate, whereas it's 12 degrees if there's less. So that's showing there really is a difference, and carbonate does have an impact on decreasing the variability of temperature. Does land use have an impact? Here's developed, here's a natural, which I threw in there, and the answer is no, it doesn't have an impact. The land use is not really impacting temperature variability nearly as strongly as the geology is impacting temperature variability. And finally, we get to the last thing you measured, which is the pH in our streams. And let's explore that a little bit. Does the geology impact the pH? And if you do a regression curve of percent carbonate and median pH, you get a fairly low R² value. It doesn't look like very much. But then if you go in and look a little closer, you can see there are 3 sites here that I circled. And those are sites where the pH, median pH, is less than 7. And all of them are in 0 carbonate watersheds. But there also are sites in 0 carbonate watersheds that have higher pHs as well. So I decided to look at it a little bit differently. I decided to look at it with box and whisker plots. And that I thought was even more interesting, because the blue one is the greater than 50% limestone or carbonate, and the orange is less than 50%. Look at the difference there. There's not much variability in the limestone with pH. And there's no outlier for maximum or minimum. It's all scrunched in together there between 7.5 and 8. Whereas the non-carbonate streams are pretty much, there's much more variability. There's high ones, there's low ones. And so at least what we can say geology is not a strong predictor of pH, but it's clear from all of this data that we've collected that carbonates do buffer streams, and they thereby preventing low pH and resulting in less variability in pH. So that I thought was kind of interesting. And then finally, does land use impact pH? And I got to tell you, folks, I couldn't find anything here. I found that R² values are low. The box and whisker, our data do not show a strong relationship between land use and pH. Okay, so let's summarize a little bit here, and then I'm almost done, so hang in there. So I want to remind you that these findings are based on Stream Team volunteer data from 61 sites. Each were monitored monthly for approximately a year for conductivity, pH, temperature, and nitrate. You know that better than I do. In addition, the watersheds for each site were delineated, percentages of developed agriculture and natural land were measured, and percentage of land underlain by carbonate or non-carbonate geology were measured. So it's a big data set with a lot of data. And the relationships that were particularly notable were the percent developed and conductivity, and these are the R-squared value. The percent agriculture and nitrate have a close relationship. Carbonate and conductivity have a close relationship, and carbonate and temperature variability have a close relationship. Our data, your data that you were able to collect has shown that. We were able to demonstrate also that the presence of carbonates buffer streams against variable and or low pH. So this is, I just think, I want to tell you, I think this is really cool. I think basically what we have here is these results are empirical evidence for all these theoretical hypotheses. And you can only get that kind of evidence if you have a very large and diverse database. And that's what we've been able to, what you've been able to correct. So let me praise volunteer monitoring. Large data sets, and our data set that we used here is over 4,500 data points on numerous streams, 61 in this case, that are geographically diverse, 5 Pennsylvania counties, and densely sampled through time monthly are rare. Only trained volunteers can collect this size database in a cost-effective manner. Can you imagine what it would have cost to have sent, a state employee out to collect all this data that we've been able to collect? It's just simply not cost-effective. So the relationships that these data demonstrate, or the stories that they tell, they really do tell congruent stories. That lends credibility to the accuracy of the volunteer data set. So I will say that this is a tribute to the effective training of volunteers, the appropriateness of the methods used, and the quality assurance quality control program. And more importantly, it's a tribute to the commitment and perseverance of the volunteers to assure consistency, completeness, and accuracy of the methods and results. So all I can say is, congratulations. I mean, these are just, I think these results are important. I think they're interesting. And I think the more data we can collect, the clearer we're going to be able to get a picture of how our streams are behaving and how land use, geology, and other factors, at some point dischargers maybe, are affecting these things. Let me just do a footnote. I didn't explore all the relationships we can explore in all the ways in which we can explore them, and I don't want to represent that I did. I just did a little tiny subset of data exploration. So if you could think of other things to do, and are there stories that are yet untold and so on, we would love to hear about that, share it with us, and see if we can, do some work in other areas as well. There are lots more questions we could ask. Okay. People still here?
We are still here, Candy. Oh my goodness. Thank you so much.
All right.
We have plenty of time now to open the floor for any questions or follow-up comments or conversation. So feel free to unmute yourself. Mark says that, yes, still here and loving it.
I would be interested in historical uses along the stream. I know that there was also a dye plant beside our stream, and they have a pond that they drew water out of. And more senior people tell me that when the dye plant was in operation, that there would be days the stream would run green or yellow, depending on what they were producing at the dye plant. Are there legacy effects from this? What's that water like? The pond that they have is pretty large. And oddly, the natural trout reproduction stops right at that dye plant. So I'm curious. I'm not saying that's the cause. I'm just curious. I'd love to know more.
Mark, could you imagine what you might monitor to assess what's going on there?
David and Nancy are having issues, I think, Nancy is having some denial issues. There's some real problems with them figuring out a place because he's a month away.
I have no idea what to monitor there. None whatsoever. Nothing that's in our current test kit
Right.
would tell us. It would take, I guess, mass spectrometry. I have no idea.
Yeah, that would definitely be very interesting. Andrew, are you trying to say something? Okay, yeah, that would be very interesting to look at the historical, maybe land uses in your area and maybe tying that to some legacy problems you might be saying. Yeah. Any other questions, comments? Oh, Charlotte, you have your hand raised, please.
Yeah, I was wondering if I could ask a question about the R-squared values, maybe for Candy. I was wondering in our context, what classifies as like a good value, like for R-squared, or like a strong relationship compared to a weaker one?
That's a really good question. And you know, the problem is if you talk to statisticians, they want to see R-squared values that are, 0.9 and you don't get those in natural systems because of the complexity. And ultimately, you probably need to do multiple regressions where you look at the relationship of many variables to each other rather than just two to each other. But I usually say, if it's above 0.3, that's pretty strong. I mean, that's been my experience. We did a lot of this with with the Marcellus Shale project that we worked on. So I've seen a lot of R-squared values in looking at two different variables. And my sense is that for me, if it's above 0.3, it's a relationship that's worth paying attention to. That you're saying that there's at least, almost a third of what's going on here, the variability that's going on here can be predicted by whatever the x-axis is, whatever the percent developed, percent ag, whatever it is. So that's pretty good. I mean, that means 2/3 is due to other stuff, but it still seems to me to be an interesting relationship, important relationship. So, but I mean, that's the big question. You can't just draw a line and say, above a certain level. You just have to, just from my experience, I would say above 0.3, it's pretty good. I was really surprised at the 0.4 that we got on the percent developed and conductivity. That was like 40%. That's really, and the great thing about this data set that we have too is that we've got such a range. It's not like we only looked at developed sites or we only looked at natural sites. We've got a range for every single attribute. We're all over the place. And so that really allows us to test some of this stuff.
And what makes some of this interesting is depending on how specific you look at the site, it changes, especially the percentage developed. It might change your definition. I mean, where whoever developed the protocol, whatever, says that my site is way down on the developed area. But at the same time, if you look at, East Pennsboro Township and Hampton Township in total, you'd say they're pretty developed areas. So, some of that, what I'm trying to say is some of that makes a difference as to where you draw the line.
Yeah, those numbers are based off of, and I don't know, maybe Phoebe or Stephanie can address this better. They're based off of maps that are produced, GIS maps that are produced.
Right.
And, they're color coded, and then you just calculate the area of the different colors.
Gotcha.
So it certainly depends on how recent those maps are. And it also depends to some extent on what scale those maps are made at and how precise they are. But for our purposes, whether it's 25% or 26% developed, it doesn't really matter, or 30% developed, it doesn't make too much difference. But that really is the best information we have on land
Sure.
use. Yeah.
You got to go with something.
Yeah, exactly. And how recent, and especially with development, because development in some areas is changing dramatically. And so how recent they are. And I don't have the specifics of how recent those maps are. Maybe you guys do. I have to ask Jenny, but they're the most recent ones we can get our hands on.
Right at Acre Meadow Park, for example, you would say that's fairly undeveloped.
Yeah.
But yet you go 2 miles downstream or 2 miles upstream, and all you've got is house after house after house after house.
Yeah.
So you're right. It depends on how those maps are drawn, and how current they are.
Absolutely. Absolutely.
From my data that I was looking at, I'd be interested in parsing out more with the relationship between water temperature and nitrates.
Yeah, it was really interesting to me that I just saw over and over again in your presentations that nitrates were higher in the winter time. And I mean, we can imagine reasons for that, like frozen ground, and people are still spreading, fertilizers, manure, and so on frozen ground, and more runoff because of frozen ground. But even so, it was kind of interesting. Yeah, I agree with you. It would be interesting to explore that more. That's a good idea. We should do that. Not sure how.
Yeah. Another season. We need another winter to see what happens with these nitrates.
I did send you, Stephanie, the link to the article. I forget where it was from actually, but seasonal differences in low flow nitrate concentrations. I think I sent you a link to that.
I think so, yeah.
If you find that, Stephanie, could you share it with the rest of us? I'd be curious about that.
Definitely.
Actually, I still have it bookmarked somewhere, so I could just send it out or resend it to you or whatever.
Yeah, do you want to put it in the chat if you have it
Thanks,
up?
Dave.
I love it. I love the crowdsourcing. Well, were there any other questions or thoughts? Okay, well, while Dave is getting the link, I'm gonna do our wrap up talk. So thank you so much for coming tonight. This was such a beast of a experience, but it happened. We did it. You all have gone through data interpretation in 2022. This was our largest data interpretation to date. And so we thank you for being patient and flexible with us as we have to navigate different programs and data and figuring out what processes work best. Also, big shout out to York County because we had to update your packet twice because we found, and you all pointed out, errors. So please never be afraid to point out that we do something wrong or have something incorrect. We learn best from you all, and you're the experts of your area. So thank you for that. Thank you for your participation. For next steps, if you were listening in and you haven't gone through data interpretation, or this was your beginning, or you have your packet and you just haven't looked yet, if you have any questions, let us know. We're happy to walk through it with you. And my Lycoming and Clinton folks, you'll do data interpretation a year from now. So you have this to look forward to and maybe preview your data as it comes in. And, you know, as we're going forward with our next steps, we are looking at making stream team reports and taking this data and making a physical type of report to show all the work that you all have done. So stay tuned for that. Hopefully that will be in the future. And if there's no other questions, Dave did put the link in the chat. Thank you so much, Dave. Yeah.
Great.
And that is it for the evening.
Thank you.